Okay, so hopefully you remember learning about osmosis when you were in biology. Okay, so this is going to come back to the idea that if I have on the left side here, I have a solution that has a higher solute concentration, okay, and over here I have a lower solute concentration, and the water is going to move through this semi-permeable membrane, and hopefully you remember what direction it moves. It basically moves from where there's more water to less water. Okay, so over on the right here, I'm not sure if we're being clear, the red things are the water. Okay, so the red is the water, and the blue is the solute. So the water moves from sort of where there's more water to less water, or a lower solute concentration to a higher solute concentration. Or you can say where there's a higher water concentration to a lower water concentration. Okay, so in this case, it's going to move across the semi-permeable membrane to the left. Okay, it always moves from where there's a higher concentration of water to a lower concentration of water. I know I've said that 6 times, but we often sort of think of concentrations as the solute concentration. So make sure you're really clear in what you're talking about. The water is moving from where there's a higher water concentration to lower water concentration. Okay, so that's just osmosis. Hopefully you learned about that in biology. Let's talk about why that is. Remember we talked about vapor pressure, okay, and our vapor pressure lowering. So in the middle here, I've got my semi-permeable membrane, okay. Here I've got water, and over here I've got a solution. Okay, so if you remember, the vapor pressure above the solution is less than the vapor pressure above the water. So what we can think of this as, this is a vapor pressure, so it's exerting a pressure in all directions, but also down on the water, whereas this is exerting a pressure, but it's really small. Okay, so it's like this is pushing the water that way, and this is pushing the water that way. So obviously this kind of wins, and the water moves from where there's more water to less water. Okay, that's still just osmosis. So what the heck is osmotic pressure? Well, osmotic pressure is the pressure that I would have to exert above the solution to stop osmosis from occurring. Okay, so it's the pressure you exert above the solution to stop osmosis from occurring. That's what osmotic pressure is. What if I exerted a pressure even greater than that? What if I decided to exert like a ton of pressure over here? I could actually get the water to go the other way. You may have heard of that. That's going to be called reverse osmosis. Okay? And that allows us to take the water from a solution and send it over into just the water. It's a way of purifying water. Okay, so it's a way, you might see this on the side of your water bottle at some point. They don't all come from like wonderfully clean mountain springs. Lots of times it's from reverse osmosis. Okay, so osmotic pressure, the amount of pressure I would need to apply to stop osmosis from occurring, and then I could apply even more if I wanted to, and I could get reverse osmosis to occur. So let's look how we calculate this. So this is your equation, okay? Your pi is your osmotic pressure. I don't know why they use a pi, except for maybe pi pressure. You know, whatever. Okay, molarity, that's your big M, molarity. R, that's our gas law constant, same one we were using earlier. Temperature, please make sure it's in Kelvin. This should look a little bit like the ideal gas law, okay? Where molarity is moles over liters. So moles over liters, and you got your R. So you have to use Kelvin. You have to use molarity, which is moles per liter. And your osmotic pressure always comes out in ATM, okay? If you use this R, and that's really the only R we're going to use, okay? 0.0821. So why don't we try a problem with that? So what's the osmotic pressure of a solution that's 0.5 molar KCl at 35 degrees Celsius? Okay, so I gave you the molarity, so this is going to be really easy, right? So the molarity is 0.5, R is 0.0821, okay? my temperature is 308, right? 35 plus 273. And what's I going to be for KCl? 1K and 1Cl, so I is going to be 2. Okay, so if you do all that out, the osmotic pressure is going to be 25.3 ATMs. And that's it. So you should know how to explain what osmosis is and why it occurs, what osmotic pressure is, what reverse osmosis is, okay, and you should be able to do a calculation.